this sort of new idea that's actually pretty cool and a little bit scary. Welcome to security. We always like to scare you. It's close to Halloween. This idea of a software-defined radio. And this is a bit of a nebulous thing in some ways, and a bit really precise in others. So what is this thing called a software-defined radio really all about? It's a gadget. It's pretty much an antenna onto which is strapped some circuitry that, because we then shackle it to a regular standard issue computer, we can do some interesting things with. It frees us a little bit because we're now talking about software, not hardware, doing our choosing and receiving and handling of data, unlike, say, a standard AM/FM radio. Get the plus sign in there. We are possessed of the ability to put very inexpensive technology. These are tiny little USB dongles usually, in the less than $100 kind of range, well, give or take, depending on how sophisticated a device you want. But they're not expensive. They're certainly within commercial prices. We have this ability to do all kinds of interesting things that even just a few years ago weren't particularly possible. They let us, let me make sure I've got the list here, they sort of liberate us from the tyranny of worrying about some of the physics because of the way they're put together. We let the device function as the picker of signal to some extent because we can tune it. This thing is no longer bound by the physical length of wire to the extent that it used to be, because we are going to target particular signals. We're going to use the computer basically as the tuning knob, and it is pretty clever at handling large amounts of data, so we can target very precisely signals we're interested in. This is kind of interesting because, if you wanted to do a giant gang of radios, you had to, in the past, you had to go buy a bunch of radios. Now we don't have that problem anymore. We have a bunch of little USB dongles and a bunch of computers, and they're all pretty off the shelf. They're standard components, they're mass produced, and they let us do some interesting things. So we can do very interesting kind of things with mesh configurations where we have multiple devices handling our signal processing and our reception, so you can get a much higher degree of granularity, a much higher quality signal. If we're doing transmit, we can do some interesting things with that too. But from our point of view, as people worried about being listened to a little bit more than being transmitted, we also have this interesting thing that suddenly you don't need a car bristling with antennas. You can have, again, we're back to things that fit in pocket, where we can receive with very high degrees of precision almost any kind of signal, and more to the point, I'm no longer dependent on twiddling a knob, so I can get very faint signals very, very effectively. From our point of view, this means, somebody doing the listening is not as bound as they used to be by some of the physics problems of they need an antenna this big to hear my tiny little Wi-Fi signal. We have the ability to get worried about if we're on the standard operating white hat end, or if we're on the black hat end, go ahead and hack things with a much greater range than we used to. So we're going to look a little bit we're going to look a bit at things that SDR, the convenient acronym for it, allow us to do. And we're also going to look at the threats these devices pose to someone trying to keep a secure infrastructure going. So just remember, faint signal means farther away listening. Oop. Try that again. Okay, that didn't turn out well, but that's okay. and a great deal more precise control of which signal we're listening to, which on both send and receive means maybe we're a little less worried about interference, or at least we can navigate around it because we're not too concerned. We also have, interestingly, the introduction of some pretty cool technology that's worth talking about. The field programmable gate array, basically circuitry that can be redesigned on the fly, which allows us to do some interesting things there, like precisely pick out a signal or precisely look at particular kinds of modulation, stuff that even a few years ago would be somewhat more problematic because I would have to go physically obtain circuitry that allowed me to do that. Now I don't have to do that anymore. I just say, circuitry, become what I need, and that's pretty cool. And of course, the ongoing problem of security generally, these things are a lot cheaper than their older counterparts, which means they're in range of a lot more people, which really changes the potential threat profiles of who could be listening, what they could be doing. And oh yeah, some of these can transmit too, so we have a risk of certain kinds of jamming being a consideration, which is a big deal when you start talking about keyless remotes for cars, people doing various kinds of payload-related attacks. It's possible, for example, to mess with a web browser, caching and DNS lookup and some other things just by diddling the signal they're sending. So we have all of the usual computer security problems can be made worse or better, depending on how you look at the problem, by the fact of we have this new player in the hardware and software, not the word software, it's really a combination of the two space that creates some interesting variables from our point of view. This one's not going away. This particular cat has escaped from the bag, and it's going to be something that opens a whole new range of possibilities and concerns that actually play nicely into this idea that, hey, we are now running infrastructure, and we have to worry about this. That's about all I want to say on that just now. Thank you very much.